And we're going to come back over this way, the way the water does.
Okay.
And I'm going to show you where things start and when they finish, and kind of, I'm going to walk you just like the water flows. Okay?
All right. That sounds like a good idea.
Camp has a maximum capacity of 150. Most of our groups are under 100. We have a few groups that are over 100, but most of our groups are under 100, and most of them are under 80. We have a lot of groups in the kind of 50 to 80 range in the summertime. Actually, we had several that were 100 or more than 100 this summer. But we have a lot of winter and spring groups that are more in the 30 to 60 range in terms of numbers. So the health department, their figures are, they figure 50 gallons per person per day is kind of for a home, what you guys would have for your home. Mm-hmm. That's what they figure the usage
That's the figure
would be.
We've heard
Here
too.
at camp, people aren't using laundries and everything, so
Right.
it's a lot less. But when we get about 20 gallons per person today, I consider that conservative, good stewardship. I talk to groups about how much water they're using. And most of the groups are somewhere 20 to 30 gallons per day per person. Mm-hmm. So you figure 100 times 30 gallons, that's 3,000 gallons a day that we would need. This summer, most of our groups used way under 5,000. We only had a couple groups that even got close to 5,000. They were like 4,600 gallons in a day. And most of our groups use somewhere between 1,500 and 3,000. So we really, you know, we produce a lot of water, but when you think how many people are here, it's not that much water.
Right.
And we're rated on our drain field for our sewage at 7,000 gallons per day. In other words, we could put 7,000 gallons of effluent into our drain field per day and be legal. But we do way below that, so I feel real good about it. We do usually way less than half of the daily allowance on our drain field.
How far is your drain field away from the stream?
Well, our drain field is way up at the front of camp. When you first drove in the driveway, all that grove of trees on your left between the driveway and our house, okay, that's all drain field. Those forested areas.
Any gray water reclamation? I know that's not
We
really
don't have any gray water reclamation, no. But we'd kind of like to experiment with that. That's something in the stewardship plan that Bessie and I are beginning to dream about, and you know, this is what we're in the very beginning stages of this. Things like gray water reclamation, composting toilets,
Yeah.
all those kinds of things are something we'd like to educate people about. Cob, those are all, you know, environmental awareness stuff in terms of alternative energy and alternative living that we'd like to be as part of our education here.
Composting for us can be problematic. I think the most they have is up to 3-4 people a day. But you can do, there's another one where they can dump the waste into huge bins and it produces methane which can be used for power. And
We can send another.
yeah. Okay, so there's lots of stuff down there.
We're walking across the bridge.
Right here is called Cove Creek, and the bigger creek is called Myrtle Creek. Myrtle Creek flows about 3 miles from here into the, it flows another 3 miles, and then it reaches the middle fork of the Coquille, and then it flows down to Bend and Oregon. It meets up with the other 3 forks of the Coquille down by
Oh, isn't this beautiful?
It is really wonderful.
I'm not going to walk your way over here, but I want to start here. Addie is on the way to the tank. That tank is that's a 1,400 gallon water. Well, it was a 1,400 gallon water tank. It's now a 500 gallon water tank because a big boulder came down the
Oh
mountain
my gosh.
2 winters ago and hit the water tank and split it. And I put in a new water
yeah.
tank. I chose to put in a smaller water tank because I didn't feel I needed that big of a tank for the purpose of it. The purpose of that tank is simply for pre-sedimentation. In other words, the spring is way up the mountain, and there's a 10,000 gallon holding tank way up the mountain that we won't walk to. It's a wooden redwood tank, and it's 10,000 gallons of water. The spring is up above that tank, and the spring comes down the mountain to this tank. It has silt in it. It's really surface water. It's a spring, but it's far enough it's like a series of little springs all coming into a basin. It's really surface water is what it is. But where we collect it, by the time we collect it in the wintertime, it's quite silty. So it comes down to this tank and it settles out there. And then it comes down from this tank across the bridge, and we're gonna walk right with the water now. We're gonna walk over.
That's above ground.
Ow, Eddie.
Yeah, that's above ground. That's just a water tank. It's the only purpose.
The line though is also above ground.
The line is above ground and partially buried all the way up to where the springs are up above. Yeah.
And then it's above ground.
Eddie,
Yeah,
be
yeah.
nice.
And probably
Be
where you
nice
live,
to
you'd
Mommy.
wanna bury your water
That's a
lines.
good girl. Be
Yeah.
nice.
Here they're just, I had crews and we kind of covered most of it, but there's places where it's just lying on top of the ground. Yeah. We don't have a lot of problem with freezing here. It's pretty moderate. I have had frozen lines here in the wintertime. These ones going across the bridge are a real problem.
Yeah, right across the bridge, that would be pretty easy.
Okay, going back across the same bridge.
Your house, I would suggest that you have a pre-sediment tank of some kind, because you get less mud and silt coming into your filters, and you don't have to clean your filters as often. So it's just, that's the reason I have it there. That's the purpose of it.
Right.
Now, someone mentioned to us that you could possibly accomplish that with a swimming pool filter, which contains sand, and you clean it out a couple times a year.
Depends on how turbid your water is. You guys talked like your water is real muddy in the wintertime. You're going to be, probably with any kind of swimming pool type filter, you're going to have it clogged up all the time with silt, I'm guessing.
In the winter.
Yeah, I've
That's
experimented
possible.
a little
When the
bit.
dog's going in.
Before I
Yes.
put in these filters, before I put in this system, I experimented with paper filters.
Uh-huh.
And
Changing them constantly, and they're
we did.
expensive.
yeah, it's not practical for us
Yeah.
anyway. And probably you guys, sounds like your water would be too. Okay,
So that was
Yeah.
the sand up there.
Yeah.
Oh, sorry.
What type
there's
of
nothing in that tank but water.
How do you collect it out of this small creek? No. How do you collect it out of the small creek up there?
Okay, I have a garbage can, a plastic garbage can. The creek's flowing on one level, and there's a drop off. There's kind of a boulder. It's just a natural setting where I had the water. Water flows down, and it pours over that boulder. Well, right down below the boulder, I have a plastic garbage can that's a 30-gallon garbage can, and I have a 2-inch line coming out of that, and it flows down. It flows down maybe 100 yards below the tank, and then I have a 1-inch line that comes off of that, and it comes down all the way to this tank. So and it's polypipe.
So it's not buried. Your system for collection isn't buried up
No,
there.
it isn't buried.
Okay.
No, it isn't
Right.
buried. It's just surface water coming down. It's pretty close to its source, but it is surface water. It's
Right.
not a true spring, what you call a true spring.
Right, okay.
And so it flows into the garbage can, the garbage can collects it, and then it flows out of there and then all the way down the mountain through a 1-inch line to that tank. Then it flows from that tank through an 1.25-inch line across the bridge here and right under where we're walking.
All right.
And over here to the filters.
Across
Here's
the bridge
filters
on
right
top?
over here.
You got it?
Yeah, right along the side there.
Oh, that black pipe. And okay. All right. Come on, Adelaide.
These are what you call slow sand water filters. You could build them out of all kinds of stuff. You could build them out of concrete tile. You could build them. I've often thought that for a household, just for one family, you could probably get like a 14-inch tile or something that's PVC, and use that, and not, it wouldn't be as much surface area. That'd give you about 1.5 feet of surface area. This has 27 feet of surface area. And the theory behind these is that they are organic. You don't add chemicals to these, like alum and things to get the particles to flocculate. There's no flocculation. This is all organic. But the theory is that you can produce from 50 to 100 gallons of finished water per day per square foot of surface area.
When you get to this
This has about a 5.5 to 6 foot surface here, diameter, so that gives you about 27 square feet of surface area. So theoretically, we could produce as much as 2,700 gallons per day per filter with this. We don't average that much. We average more, somewhere about half of that to 3/4 of that per day per filter. And I built, this was the first filter, and then I added a second filter because of the amount of water that we have to produce here. I needed to make 2 filters.
So how does the water get split and go into both of them?
Okay, it's just one line coming in where we just walked, and it just tees off to this one and it tees off to that one. It's
And-
that simple. It goes into the top.
The pressure is high enough so it'll send it into
Yeah,
the top?
that's
Oh.
right. It goes into the top of the tank. Now the tank, and I have schematics which you can photocopy that I drew up of this particular system. In the bottom, about this high up,
Okay.
there is 1.5 inch drain rock, and it's just
Excuse me, Bessie,
it's
thanks.
just drain rock. It's big drain rock. It's like
Yeah.
that size.
Yeah.
And right in the middle of that 1.5 inch drain rock, like about this level, I laid drain rock, and then I laid this 1 inch pipe on top of it. Inside there's this is 1.25 inches,
Right.
but inside there's a 1 inch pipe, and that 1 inch pipe is kind of this shape. It goes right to the other side of the tank, 5 feet across, and then it has legs coming off of it, like
Okay,
3
like a
legs
ring.
on each side, and the bottom of it has little cuts in it every 3/4 of an inch or so. I just took a chop saw and I just went zip, 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 zip,
Little
zip, zip,
slits, yeah.
and just cut a whole lot of little slots in the pipe, and that's on those legs, and that's called a manifold, okay? And that manifold is the water collection pipes, and those slots are facing down. So you've got, and then I put more 1.5 inch gravel on top of that. Then I put, I don't know, this, I have to show you the drawings, I have it all drawn out, but I'd say another 7 inches or so of 3/4 inch drain rock on top of that, a little finer drain rock. Then on top of the 3/4 inch drain rock, I put pea gravel, and I put a whole bunch of pea gravel in. And that's kind of, you know what pea gravel is, it's kind of a fine,
Round.
gravelly, sandy type stuff.
Yeah.
And then on top of that, I put in a concrete mix. And that's finer yet, but still quite coarse. And then about the top,
Concrete mix, not with lime or?
no, just they
sand.
call it
A coarse
concrete mix.
sand?
It's just a
Okay.
coarse sand. It's
Sharp
like Mason
sand?
sand.
Yeah.
Mason sand is real expensive to buy by the
Yes,
sack.
right.
So you can usually find a spec sand, what they call spec. They have specs on it. You know, they have data that
Right.
shows that it's so many particles per million that go through a certain size screen.
Okay.
So, and I'll teach you a little bit about spec sands. But about the top 1.5 foot is dune sand. Well, the dune sand's right to here, so it's about this much dune sand, maybe 2 feet of dune sand.
Did you wash it first?
I didn't wash it first. I just got it from Bracelet and Jaeger. They had huge piles of it, and what I had done is this took a long time to do all this. I did lots of research, and I'd take different sands and I'd put them in a glass of water, and I'd stir them around and count how long it took for the dust to settle into the
Right.
bottom of the glass, that kind of stuff. I just did a lot of horsing around that just took time, you know, because your local sands, you don't want to run clear over to Umpqua dredging where I got my stuff, which is up by the other side of North Bend, you know, up
Yeah.
in Reedsport. I mean, you'll find local sands
Right.
that will suit your
Yeah,
purposes.
there's
over
washed
there.
river sand. That's
Yeah.
what I got for the sandbox. Yeah.
So the dune sand was really fine sand, and there are river sands that are as fine as the dune sand. There was one of these filters made by the state of Oregon for a state park down by Port Orford that I went and looked at. That's another thing. You'll want to look at while you're doing this, you want to go look at some other people's slow sand systems. Talk to them, and I've got a list of people that around the state of
great.
Oregon. I've got a list
Great.
of every slow sand system in the state of Oregon. There's about
Okay.
25 of them, including the city of Salem. But anyway, so you've got gradations of sand and gravel, and the purpose for that is that when your water starts coming down through, it doesn't wash all your sand down through and block up your manifold, okay? So the more gradations of rock and gravel you have, the less settling of sand you have. And you don't want that fine sand all in and up in the bottom. That
Right.
happened when I first built this. I didn't have enough gradations of
Yeah, I
gravel,
almost don't
and I
understand
ended
why
up
that
with a lot
wouldn't
of my
happen
dune sand
anyway.
down the bottom.
Yeah.
Did
I
you
had
have
to
to
dig it
redo
all
it?
out.
Oh, man.
Well, you do that, you dig it out anyway.
No,
Or
he
you just
doesn't.
skim
No,
off
I
the
don't.
top?
Skims off the top, he told
We
me.
built
yeah.
these filters, I think 94 is when I got these online. 93 I got them online, but I had to test them in a pilot study for the state for a year. So sometime in 94 I started running them and actually producing water for camp. They made me do a test study for a year before I could use the water for camp. And so since '94 we've been running these, and I have never cleared all the sand out. What I have done is I used the sand, here's my line for dune sand here, I used it down, here's the line for the pea gravel. So I used it down once, completely used it. Every time I clean these filters, which is anywhere between once a month and once every 6 months. Usually I clean them about once every 3 months. You guys once every 6 months is
Probably,
it depends. If your water has a lot of algae in it or something, you'll have problems.
Yeah, it does.
You'll have problems with having to clean it more often. I've been really lucky here with algae problems. I haven't had those problems. But probably realistically you would not clean it more than once a month.
Depends on what time of year it is, I
and
think.
probably not less than 6 months.
How's
Yeah.
the filter that you clean?
Huh?
Where's the filter that
Well,
you clean?
this whole thing is the filter. So when I clean it, I shut off my intake. This is the intake. This is the water coming in, and I shut that off. And there's a drain down here, and I put a garden hose on it, and I run the garden hose off away from the building, and I just drain it down to where it is below the surface of the sand. The surface of the sand is right here. See how when the water collects in the manifold, it comes through here, it goes up, and this Greek key takes it over. The reason for the Greek key in there is so that there will always be water on top of the surface of the sand. Okay? You'll always have wet sand, and the reason for that is the bacteria layer that you grow.
Yes.
You want that bacteria layer to survive. So the surface of the sand is right in here, and what I've done is I drain the water down below the surface of the sand, and I usually just drain the tank dry. And then I climb in from the top, and you've usually got about, you've got about this much what they call smuts deck. Smuts deck.
Who calls it that?
I call it the smuck stack. And it's smuck. It's just mud that's come in. And that smuts deck is full of live bacteria that are good bacteria, natural bacteria. There's natural bacteria in our water system. And those bacteria eat other bacteria. They eat stuff like Giardia. So when Giardia gets introduced into this, or fecal coliform, for example, other coliforms, they come in through the water, and that smuts deck is full of live, healthy bacteria, and they eat that other stuff. And that's the active part of the filter. That's what cuts down your coliform and stuff. And you can see my results. It's amazing. They're usually like 98% or higher reduction of coliform. I had to do pilot studies where I took the raw water and I sent it to the lab every 2 weeks, and then they finally let me start doing it just once a month. But I took raw water and sent that sample, and then I took the finished water before chlorination and sent that, and then I took the finished water after chlorination and sent that. But between the incoming raw water and the outgoing unchlorinated, untreated water, but the filtered water, there was like 98%, 99%, 99.7% reduction of coliform. It was really amazing.
Do you
it
still
really does
chlorinate
work.
the water after it
I
leaves
still
here?
chlorinate the water. Now, whether you guys would need to or not, you're a family, you live in the area, you probably have some resistance to whatever coliform.
Your guests don't necessarily.
Yeah, so you may not need to treat your water. I have to treat it because we're a public facility. So even though, for us to drink it or Bessie to drink it, we're local folk, we probably wouldn't be affected by what little coliform there might be. We could probably drink it right out of this tap now and we'd be fine. So, but for user groups that are coming here from Portland and stuff like that, we chlorinate.
Have you found any cryptosporidium? Because we were told that it has been found around here.
Yeah, none of my tests showed that. I mean, none of our pilot study tests showed any of that. It was mostly, there was some Giardia, and there was some, and that was completely wiped out with this filter. The Giardia didn't survive at all. It was gone after the finished water came out. And there was some fecal coliform, and that was almost totally wiped out. And it was totally wiped out in some of the months, and it was all but totally wiped out in other months. And then there was other coliforms, and they were, almost totally wiped out. So
So when you take off that layer of beneficial bacteria, it's also good and bad.
Right, so yeah, I was going to get to that. When you clean it, when you scrape it off, I usually take about 1 inch of sand with it. So I take off all that smut speck, and then I take off about another inch to sometimes 2 inches. It just depends on how far it's permeated down through, how much I take off. I take it down to where there's clean sand, where I don't see any more streaks of brown muck in the sand. So sometimes it's as much as 2 inches. Usually it's about 1 inch of sand with the smut stick. And then I climb out and I rake it all down, and then what I do is I back flush it. I take regular water from the system, finished water, out of that spigot right there, and I back flush through the manifold, and so it charges water up through the sand. And that blows out the manifolds. It cleans out all the manifolds, any sand that might have filtered down through the manifolds, and it refills the tank. And then I don't put it back online. I run it, but I just run the water off away from the buildings for a few days, usually 3 or 4 days does it. That allows that bacteria layer to get all healthy again and operating. And one time during my pilot study, during the year that I was doing the pilot study, I cleaned that tank. It was that tank. I cleaned it, and I used the water. I did the sample like the following Monday or something. I cleaned it on a Friday or something, and did it the following Monday. And that was the one time that I had really low effect from the filtration in terms of getting rid of coliform. I had like 75% reduction instead of the normal 95 or higher percent reduction. That was the one time, and I decided, you know, that was enough to teach me that you need to let the thing have a chance to rebuild.
Regenerate, yeah.
So now that I have 2 filters, it's real handy
it's easy
because
to
I do it at
let
a
it
time when
rest.
we don't have lots of people here, so I can
Right.
get by with 1 filter. I clean the other filter. I give it usually 4 or 5 days to recharge, and then I put it back online.
What's this?
This happened to come on this tank. It's just a clear sight level. It just tells you how much water is in the tank.
Oh,
And
you're supposed to be able to see into that.
yeah,
I gotcha.
yeah, stuff is grown inside
this?
of there.
That's for
And that's
telling
a little flow meter.
how much water is going
Yeah,
out.
and right now it's, well, I shut this off so that could, well, actually, it's probably not a lot going out right now because our tank
draw.
on the hill is almost full, and I have float levels on the other tanks
Yeah.
that shut it. These don't flow constantly. They flow as the water is needed. And it's kind of like a toilet float. Like on these, there's toilet floats.
Yeah.
The flow coming
got
in,
those
once
too.
it gets so high
Yeah.
and it's up, this toilet float floats up and it
Right.
shuts off.
Yeah.
As
We got
we
those
need,
too, I
as we
Much
use
spider.
water, as we use water, the toilet float will, the level will lower, and the toilet float will go down and allow more water to flow in. And the tank that I'm going to show you in a second has a float on it too.
This is 1,500?
This is a 1,300, 1,400 gallon tank. And I was going to mention that the diameter of the tank isn't so important, because for your
Right.
home you might only need a tank that's a couple feet, 3 feet in diameter. But it needs to be tall enough
Yeah.
because you have all
Yes.
these levels of sand. So
Right.
you figure at least 8 feet. You need about
Yeah,
8 feet.
8
Okay.
feet, okay.
Now the heavy black
Sunlight
plastic.
permeable.
You don't
Plastic.
have an algae problem with them, huh?
It's
I haven't
shaded.
I haven't had any algae problem. There is a time of day where some sunlight comes in here,
But not
but
enough to...
I haven't had the problem. The guy down at Port Orford who was doing the state park filter, his were right up in the trees, and he had lots of shade,
Yeah.
and yet he had a lot of algae
Oh,
problems. So
okay.
I think there's more.
What kind of
I
plastic
can't
do you
answer your
use?
question very well, but I think there's more to the algae problem than just sunlight through the tanks. I think it's the water.
Well,
Yeah.
we noticed the
that you
difference
have.
between the 2 tanks we had. One was like this, but it was black, and it still allowed a lot of algae or growth in it from the sunlight. And the our other one is heavy black plastic, doesn't allow any sunlight, and we didn't have any algae in
Oh,
that
good. Well then,
Well, we just...
Well, one
I
is
used
new
heavy
and one
black
is old too, which,
And
you
coordination
know.
system went off for a while.
yeah.
Yeah.
Now, when you after you clean this, you fill it back up with water and let it stand for 4 days or so.
Yeah,
Okay.
I'd
I
say-
wanted to make sure you
yeah.
filled it back up first. Okay.
4 or
That's-
5 days. Yeah, you fill
And
it back
then-
up and get it flowing. I run it, and then I open this valve down here, or right here actually, and I run water. I'm actually using the filter. It's flowing, but it's not going into the other
I see.
system.
Oh, okay. For 4 days. All right. All right. Is there somewhere else?
4 or 5. I'd say 5 days.
Okay.
Maybe I should just send you a copy of the
Now, when
videotape.
the
You're taking
water-
all these
Yeah, that'd be
notes.
great.
The water
You know, he
that's
might be
coming,
able to use
let me
it,
show you one
actually.
more thing before we
I
walk
could
over
make him a
this.
copy.
The water that's coming out of the bottom of this thing is going up here, and it's going down here, and it's going right back over toward the bridge, okay? And I can shut that water flow off here, and I can shut it off on the other one as well. And I've got lots of valves. This is a valve for draining. This is a valve for shutting things down while I work on it. This is a valve for the incoming line. So my diagrams, you won't have to remember all this stuff. It's just like some diagrams. Chlorinated or anything at this point. It's just filtered.
Right.
And I'm gonna show you my turbidity meter. It's a machine that you measure the cloudiness of the water. I'm gonna show you that in a little bit. But we can take some raw water going into the tanks and run a turbidity test, and we can take some finished water coming out of the tanks and run a turbidity test. And then we'll take finished water that we would drink, and we'll run that and look at it on a turbidity test. And that'll give you an idea of how effective the filters are.
Come on, Ed.
Here, 2 1/4 inch line. Goes right under the bridge, right into this little shed. This is my pump house. Remember I said that I have a 10,000 gallon water tank on the mountain? That's our storage tank. You guys won't need a 10,000 gallon tank, but when you have 130 campers here and you run out of water, it's a really bad deal. So we have a 10,000 gallon holding tank. So the filtered water gets pumped. The filtered water flows over into this sump right here. I call this tank a sump tank. And you can look inside it, there's water flowing into it. And the water that's flowing into it that you hear running, that's the filtered water that's coming out of those filters. And so it's flowing into that tank. Now that tank has a float in it, like a mercury type float that when it goes down it shuts off. When it flows up, it'll turn on. On my big tank on the mountain, there's electrical lines that go up to it. It has floats in it too. So when the big tank gets so low, it tells this tank that it needs water. And this pump right here, inside that pipe right there, that green and white pipe, is there's a submersible pump in that. That's a pump housing right there. And this is a chlorination bin, and that little blue box is a chlorinator. Okay? So what happens is finished water flows over here into the sump, and then when the tank on the mountain tells this sump that it needs water, this pump turns on and starts pumping water up the mountain. As it pumps water up the mountain, this chlorinator is electrically keyed in with the pump, and it automatically kicks on and it starts pumping chlorine at a measured amount. And I've got this blue tank here is a chlorine solution, and it's like a gallon of chlorine for 30 gallons of water. But I can set that chlorine
Ours is
meter
1 to 8.
so that it sets a measured amount.
1 to 30?
Yeah, but that's just the solution. That's not what is
solution.
actually being shot into the.
I know, but we do 1 to 8.
Oh, really?
Yeah, and then it drips it into the.
Okay.
Yeah.
Well, mine's a 1 gallon to 30 gallons of water, and then it's being injected in very small amounts. So
Yeah.
I try to keep my chlorine at 0.5. They require 0.2 to 1 for the chlorine level.
Right.
I try to keep mine as low as possible and yet safely above the minimum.
See, we're treating completely different water than what you're adding the
Yeah, ours
chlorine
isn't
to. We're
filtered,
adding it to creek water.
Yeah.
So
well, then
you have to add a lot more.
higher
Except we don't
chlorine
drink
is
it.
necessary. Plus, you're drinking all that chlorine. I mean, that's not.
We don't drink it.
Oh, okay.
Showers
Okay.
and
Okay.
laundry and bathing.
Great.
So you pump it back up the hill so that you get the
So
pressure.
it gets pumped up the hill to the 10,000 gallon tank, which is way up the
Is
hill.
that a plastic tank or?
It's a redwood tank.
Oh.
Redwood tank.
Oh, nice.
And then it sits up in that redwood tank, and we figured out based on how many toilets we have and how many showers we have and how many kitchen sinks and everything we have. There's mathematics, and of course it probably doesn't really work out that way, but mathematically speaking, they can calculate how much water you would use if you had all of those valves, all of those toilets, all of those
Open at
kitchen
once.
sinks all flowing full blast at the same time,
Mm-hmm.
how long it would take water, that as soon as you opened them all up, how long it would take water up there to get down here to go out those toilets and stuff. And
John?
they figure 197 minutes. And that was all done with mathematics from the State Health Department. And I just,
From down here, starting down here.
starting, if you turned on every toilet in camp and every sink and everything, including our house, the whole works, theoretically you have what they call 197 minutes of contact time. In other words, time that the chlorine is in contact with the water before it comes out the faucets, okay? And that's all theory. In actual fact, we have far more contact time. We have hours and hours and hours of contact time because we're not using water at that rate. And so you actually, the water that goes up there is actually in contact with the chlorine a lot longer than 197 minutes. But
John?
they do that. The State Health Department does everything based on the worst possible case scenario. You know, where you were using so much water that somebody theoretically could get some untreated water in their toothbrush kind of idea.
Now, how do you pump up to way up there? What kind of a pump do you use to pump at such a steep?
The pump is inside of this housing right here.
Yeah.
It's a submersible pump, and it pumps. I have the statistics on it in there. I think it pumps over 200 pounds pressure at about 15 gallons per minute. I think that's what this pump is rated at. It's 15 gallons per minute at 200 pounds pressure.
So that's about an inch and a half pipe then that it goes through up?
It's going up in an 1.25 inch pipe.
Inch and a quarter, okay.
And then the finished water, with all the chlorinated finished water with the chlorine contact time and everything, that water comes back down again to camp through a 2-inch pipe,
2 inch, okay.
a 2-inch line.
Okay.
And it goes all the way up through camp here, and coming off of it, there are 1-inch lines that supply all the buildings that need water. So,
Now, when you say that submersible pump there, what's it submersed in? Is there a big, huge tank coming from those then under here?
No, it's just submersed. See this pipe this is an inflow pipe right here. The water's coming in from the filters. Down under the ground right here, there's a pipe, I think it's a 2-inch pipe, that flows into that housing right here. It's hooked into this housing from the bottom of this tank. And the pump hangs right here. The top of the pump is like right in here, and the pump is hanging in that housing.
Oh, so it doesn't have to be covered by like 12 inches of water or anything?
No. Well, the pump is totally submersed in water, There's a rubber gasket in here. This is bolted down, and this is watertight, okay? So this whole thing is full of water. This whole
But it's not
tile
much
is
deeper
full
than
of
that.
water. It's deeper than that.
Oh, it is.
It goes down maybe that much deeper in the ground. We probably can't.
And it's
probably
continuously
about
fed from that.
Yeah, and it's a pipe about this size right here. Actually, it's a 2-inch pipe. This would be an 1.5 inch pipe. There's a 2-inch pipe in the bottom of this tank. The tank's down in the ground about that far. And there's a 2-inch pipe that's hooked into this housing right here.
But at the bottom, huh?
Yeah, at the bottom.
And then it forces it all the way up?
It forces water right up through the pipe. Yeah. If you started unscrewing this right now,
You'd have a lot
without
of water
shutting
coming
off
out, huh?
the valve, water would start squirting out of here.
And that's only from the pressure from those tanks over to here, huh? There's enough of a drop.
That's actually only from the pressure from this tank right here.
Really?
Yeah.
Okay.
Yeah, it's just gravity feed. This tank is, when this tank is this deep, there's a lot of water in that. So it's just water's gonna seek its own level.
Okay.
And of course, when this pump is pumping, it's sucking that water out of that tank, in essence. I mean, it's pumping water out of here, and that tank is filling it back up again. So you've got a suction involved. Okay, so the water goes up the mountain to the 10,000 gallon holding tank, what we call the holding tank. And that chlorinator is an expensive chlorinator. And the reason most chlorinators are not expensive. You can get a good chlorinator for under $100. But that chlorinator has a pressure on it that's over 200 pounds pressure. That's to overcome the pressure in the line. When this thing is pumping, you've got 200 pounds pressure, and that has to do with the head from all the way up the mountain.
Push it back down.
So you have to overcome, we figured all that out mathematically too, that the pressure from up the line, there's something like 150 pounds pressure So that's why we have a pump and why we have a chlorinator that are both able to overcome that amount.
So you're not just, it puts it in the line as it's going up the hill.
That's correct. That's correct. And it puts it in the line right over here. See this little tiny white hose coming out of here? It's a little kind of clear white plastic
Yeah.
hose. It's injecting into the line right there. This inch and a half line right here that's coming out. This is going up. This is the water going up the mountain. And as it goes up the mountain, the chlorination is injected into it right there by where
that's
that
kind of like the way ours
where
works
that
too.
valve
Yeah.
is. Or that gauge, rather, where that gauge is.
Our chlorinator just suddenly stopped working, John, and we weren't aware of it until the algae smell of our water got so foul that it made you want to throw up.
Well, I got a little chlorine tester over here in the house that I'm going to show you that's really cool. It makes checking chlorine, instead of those swimming pool chlorinating things, it's a real nice little tool. I'll show it to you. You can probably buy one over by you guys somewhere.
We did just buy one. I hope it's the same
got a little
kind.
wheel.
Yes.
Yeah, those are
just
real
bought one. It's $100 with the little pillows.
Was it that much?
$100. It's $1 a test,
Oh,
essentially. Well,
$1
not when you buy the
test.
refills, because you've always got the color wheel and the.
The refills were $39, I think, for a small bag, though.
I
That
get
was
they're
years
50.
old. Years
I
old.
get 100 in a bag,
Yeah.
and I did. Are they $39 a bag?
Well,
I'll
that
show
was-
you what
that
I
was
got
years ago.
anyway.
Yeah, we just got ours.
This is all my whistles and bells and stuff. This all looks a lot more complicated than it really is. You know, once you kind of get to know the system, you figure things out. But I learn new things every day. This is the pump. This is my pump that's pumping the finished water up the mountain with the
the one in the
chlorine in it.
greenhouse.
Right. This pump is a creek pump. Now in the summertime, like about July, mid-July, our spring starts to run. It doesn't run dry, but it runs really, really low. So from about mid-July, we have a backup pump in the creek.
This creek?
Yeah, this creek right down here. And that backup pump is up creek here, and we have a water right and everything on it. It's right outside the old bathroom buildings. And in the old days, the way the water system worked is we had the spring that just came straight down the hill. The spring ran into the great big tank on the mountain, okay? And this is like, we're talking 18 years ago when I first came here. And it came down across the bridge. It was just totally untreated water. It was just water right out of the springs. It came right into this building, and right inside this little shed, there was a mechanical chlorinator. And when it moved a little Pelton wheel around, it kicked in chlorine. Each time the Pelton wheel went around, it kicked in chlorine. It was not electric. It was just a mechanical, big brass-looking thing. And it kicked in chlorine into this building. And that was the treatment. That's all the treatment there was. And so in the wintertime, the same water that now I'm filtering over here that we found coliform and things in was basically the water that for years Camp had used. Go straight in the kitchen, and you'd have some chlorine contact time, but if you were running a lot of sinks in there,
Yeah, not much.
theoretically you wouldn't have any chlorine contact time. There was
goodness.
an 80-gallon pressure tank in here and I think a 60-gallon pressure tank in here. And if you used that water down fast, you'd get to a point where you had no treated water. So it really was not an adequate system. You know, and when I started learning, when I started working with the health department and learning, I started thinking, wait a minute, you know, we really don't have adequate safe water here at camp. So I started working on this about 17 years ago on the thing, and I put in whole new water lines, and it's a long ongoing thing. But as part of that old system, there was a pump up by the bathrooms that in the summertime would pump water directly out of the creek right into an 80-gallon pressure tank up in the old bathrooms, and that had an electric chlorinator on it. And when that pump kicked on, it was just a 1.5 horse pump. When it kicked on, it would also kick on the chlorinator, and it would chlorinate that water right into the 80-gallon holding tank for the bathrooms. And kids would be washing their hair and taking showers. Well, it was the same thing. There was no chlorine contact time. Theoretically, you were chlorinating the water, but that's all you were doing to it. And in the summertime, the creek water is not very turbid. It's very clear. If you look at it, it looks clear. If you put it in the turbidity meter, you see there's a fair amount of turbidity. But it was fairly clear, and that was it. So you had the spring for all drinking. And we had a system where you could shut off. You could just use the bathrooms. There was only one bathroom building in those days, and that could all be creek water. And the rest of the camp was the spring water. And I'd be crawling around on the mountain in September trying to dig out every little tiny hole of water there was, okay? When we replaced the system years ago, we put in this new system where in the summertime when we get low on water, that pump that used to supply the bathrooms instead pumps water up along the creek. Here it's on the surface up here, it pumps it out of the creek, comes up, goes across the bridge, it goes to the same filter that the spring water brings in.
You mean the settling
the
tank?
settling tank, right, or I said filter, I'm sorry. The settling tank, and so it settles out, okay? Comes over, goes through these filters, and is filtered, and then it gets over here to the sump, and then it gets chlorinated and pumped up the mountain. So it's all the same water in the summertime for about 3 months, until about until about now. You know, there's more spring water coming in now because we've had some rains.
Yeah.
But usually until about the end of September or even middle October, we rely on the creek for backup water, and that's all been through the same pilot tests and everything. So it's all part of the system. But so we have 2 uses. So what I'm thinking is your water should be fine if you put in a slow sand filtration system.
Absolutely.
You should be able to do this too.
I think so. Our we don't trap it off the surface, have it flowing into a bucket or anything. We have a pipe that's slitted along its length. It's a big diameter pipe that's in a sock with pea gravel on top of that, and then big rock on top of that.
You have some kind of tiles in the creek or something, concrete tiles, or you have like
no, it's just a big white PVC 12-inch pipe.
Okay.
And it runs for about 20 feet in the creek on the bedrock.
Right.
And then there's gravel around that, and then, no, I think it's pea gravel first, and then gravel, and then big rock. But it's in a sock already. It's in a sediment sock. And so the water that comes out of the creek,
it's already
it's really pre-filtered a little bit in that way, you know. So we didn't have a lot of sediment in the big new tank that we had. We had a lot of algae in the old tank, but not a lot of sediment in the new tank. So I don't think we're getting too much sediment.
Yeah, my border collies get down into this
they
pool, though,
they
muck
like
it
to
up badly.
splash right around the pump.
in the wintertime, this creek becomes like a raging river. It really does.
Yeah.
The big logs come down this creek, and it's really muddy. So it's like we wouldn't be able to. People do pump out of like Myrtle Creek in the winter, and they pump out of the Middle Fork of the Coquille, and it's just like brown. Our water in the winter, we have plenty of water in this.
Sure.
Like I say, from about the end of October all the way through till about the middle of July. We have lots of water on the mountain. And that water also gets pretty brown in the wintertime sometimes. I mean, it's what I'd call chocolate brown. It's not dark black muddy, but it's brown. It's definitely very brown.
Like root beer almost?
Yeah, sure.
That's just that's just being stained by the woods, right?
Well, no, it's silt.
There's mud in there too?
It's mud. But that all gets taken out by these filters over here. So in the wintertime, if we had as many campers in the wintertime as we have in the summer, I'd have to clean those filters more often. But because we have less people, I can let the flow get down in those filters to about 1 gallon per minute per filter, and I still have plenty of water. 1 gallon per minute per day is 1,400 gallons a day. If you have water flowing at just 1 gallon a minute, that's 1,400 gallons a day. That's a lot of water. That's far more than your family's going to use in a day.
That's all we get from our well.
You're going to use maybe 800 gallons a day, I'm guessing.
Well,
we use 10
we need a
gallons
lot for
person.
gardens.
We're so low.
Well, then you're way below that. So with a filter like one of these that I built, you guys could be producing clean water for not only yourselves but your neighbors, and you know.
And if we had a big enough holding tank like you do, the 4 days of downtime when you need to do the cleaning would not be a problem.
You could probably have a holding tank about the size of one of these, actually. It sounds like you already have
We
some.
have 2,500 gallons tanks. We have
You
1 in
already
use
have a
and
big
2
enough holding
waiting.
tank. Yeah, you already have a big enough holding
Yeah,
tank.
we do.
We want
Because we got 3 of them.
If something happens and we have no electricity, that we have a lot of water.
Yeah. Well, that's what you want. You'd want to take your finished water, whether it's just filtered after these or whether you've added a little chlorine to it after you've filtered it, whichever way is your finished water, and have that in a holding tank. And you could put it in the holding tank, and then you could just hand feed chlorine too. You could I'm sure that you could figure out, based on how much water you personally use each day and your chlorine testing, you could figure out how much chlorine to add, whether it's a quarter of a quart or But it'd probably be far less. It'd
Or
probably be a
do
half a
without
pound.
it since we're not a camp.
Yeah.
Once we get through treating the water,
That way needs sand.
But I mean,
You
and
don't need to.
yeah,
but what I'm saying is, if you wanted to,
if we wanted,
would not
we'd
even
rather not
necessarily need a
chlorinate if we can
chlorinator.
help it.
you could
don't
figure
want-
it out
really
over time.
don't like
Because I've
chlorine.
had periods where my chlorinator went down, and I hand-fed chlorine, and I just know, based on how many gallons a group is using, about how much chlorine I have
Right.
to hand-feed to
Yeah.
keep it going. Like, my chlorinator broke down this last June, and it was down for about probably nearly a month before I had to special order this
Oh,
one.
yeah.
So I was hand feeding that whole time, and I was very accurate. I had
What do you
Uh-huh.
hand feed in?
just chlorine, just
But where?
liquid bleach. Well, I just poured into this sump right here. This
Oh,
Yeah,
okay.
yeah,
yeah.
yeah.
I just poured into that, and so everything that gets pumped pumps up
Uh-huh.
the mountain.
Uh-huh.
And I would just, for most days, I'd just put in like a half of a quart per day, like a pint per day, and that worked out to just about the reading I need, which is 0.5 on the chlorine.
Right.
But that's I've learned that over years. You know, I mean, that's
Yeah.
just from experience. Once out of the creek and down the mountain, over to the filters, from the filters to the sump, from the sump through the chlorinator up to the big tank. Is held in the big tank for chlorine contact time, and then flows down the mountain through a 2-inch line, all the way up through camp, and off of the 2-inch line or 1-inch lines to each building. So that's the
Carry me, Mama.
the pH of the water and the amount of chlorine in the water all work together in terms of what they feel is adequate.
Okay.
Okay, and then turbidity too. You also factor in turbidity.
What
So
temperature are you
this
looking for
temperature
there?
is saying that I have a 54. This is 54 degrees. Okay.
Okay.
And yesterday morning when I checked the temperature earlier, it was like 48 or something. So there's a fair amount of temperature variation during different times of the day. This little vial here, I just fill up to the bottom line.
Oh, I've been filling it to the.
No, just to this line right here.
Oh, I've been filling it to the wrong line.
Yeah, just the first line.
Oh my goodness. Okay. I've been filling it to this one up here.
Unless I've been doing it wrong all these
Oh my gosh.
years. But no, I think I got it right.
Okay. Well, I'm
Sure you
glad.
do.
I'm glad to see you do it now.
I've
Because
had the guys from the state come in here and use my thing and everything.
do it, and you
Yeah.
saw them do it that way.
Yeah.
Okay.
My God, you're wasting water.
And then you just run your water wheel to where it's about the same thing.
Right. And then read the numbers.
And that looks like 0.3, 0.4. 0.3 to 0.4.
Okay.
I'll call it 0.3. But I would imagine some. Yeah.
More than the plastic ones,
It
probably?
depends. Maybe. I don't know. I'd have to think a while about that. But yeah, I don't know if you'd have more than the plastic tanks or not. But I'd imagine you'd probably have a little less evaporation. Of course, if you had a black plastic tank with lots of sunlight flowing on the black plastic tank, you may even get more evaporation.
Yeah.
Okay, this is a turbidity meter. All it does is it measures the amount of particles in your water, and they have what they call standards of measurement called NTUs. Something I could look it up, but N stands for something turbidity units, and the something is the fancy word that they use stands for particles that are suspended particles.
Oh, yeah.
So this thing that I have in here is a standard, what they call a standard. It's a sealed standard. I just bought this one last month, September 2002. You need, if you're going to get into this the way I am, you buy one of these about once a year.
Really?
Works.
Is that distilled water then?
It's a solution. It's a chemical,
Oh.
but it's a particular. This is 0.5 turbidity. This solution is guaranteed by some laboratory, Wattman Labs, or this one's made by. This is an AMCO standard, and it's people I bought it from. Are called Advanced Polymer Systems. They're down in Northern California. They guarantee that this fluid in this vial right here is 0.5. Okay? NTU.
So first you
So-
test the...
So I have the 0.5 NTU, and on my meter, see you're reading these little, I have it
Yes.
set on point 1. That shows that each one of these little lines is 0.1. This is 1 NT, it's 1/10 of an NTU. So
Okay.
0.1, 2, 3, 4, 5. So this is 0.5 NTUs.
Okay, just like it should
Then
be.
I take my little test tube jobber dobber and run over and
Alright.
grab some water. In. Give it a couple spins, that gets the water bubbles
Oh,
out. 'Cause
okay.
this works on a refraction principle. Halfway down through that tube, there's light coming through a little hole. The light shines through into the test tube, and bounces off of particles. It bounces off of air bubbles too. So if you have a bunch of air bubbles in there, it's going to show you a high turbidity. So I usually let it settle down a minute, get the air bubbles out. This is reading today. Oh gee, it's way down. We haven't had a group, see, since yesterday.
Everything's settled
Yesterday
down.
was Sunday, or was yesterday Monday?
Yesterday was Sunday.
So the group left yesterday afternoon. So we're reading 0.15 NTUs. So 1.5 tenths, 1500ths NTUs is what, and that's really good.
Clean, yeah.
What they require for fast sand filtration, real quick note, fast sand filtration is what most cities use nowadays. Because they need so much water, they can't fool around with slow sand filtration. Salem, Oregon has a slow sand filtration system.
Really?
It's acres. It's acres. They actually use little tractors to go out and scrape it off when they scrape it. But most municipalities can't afford the land, and they can't afford the personnel power to do all the
I would think
maintenance
there'd
that's
be a lot of
necessary.
evaporation too.
Yeah, there'd be some. But anyway, there are cities across the United States, most of them in the East Coast, who have had slow sand filtration systems for their city water supply since turn of the century. A lot of them were built in the 1930s too. There were a lot of slow sand systems built in the 30s. I'm not sure when Salem put theirs online. There's 25 slow sand filtration systems in Oregon, but all the other municipal filtration systems, most of them are what they call fast sand. What they do is they force water through sand very rapidly. It's under pressure.
Well, that's like a swimming pool
This is all
filter
gravity
does.
feed,
Yeah.
our filters.
Right.
So
Yeah.
because you force it through so fast, there's a lot of things like giardia that don't get taken out,
Right.
So they use flocculants, they use chemicals like alum to
Yeah.
make the particles flocculate and stick together. The more of them stick together, the more chance you'll get of getting those giardia
Right.
trapped in the sand. Otherwise, giardia just pass right through because they're really minute, really tiny little organisms. So they use chemicals to flocculate, and
Excuse me.
the fast sand filtration, they require municipalities or any public water supply like us, if we had a fast sand filtration system, we would not be allowed to have turbidity measurements that are over 0.5. 0.5 is the lowest, or the highest we could have in terms of our turbidity. We have a turbidity of 0.15.
Yeah.
Okay? And 0.5 would be our highest that we could have if we had a fast sand filtration system. With slow sand filtration, because of the active part of the filter, the killing off all the coliform and stuff before it's ever chlorinated and stuff, they allow us to have a 1.0 NTU. So if I measured the turbidity today and it was, say, 1.5 instead of 0.15, that would be too high. But it's much higher than what they allow for fast sand filtration systems. It's twice as high.
Yeah.
And that's because of the active part of the filter, the coliform.
And yet you don't get it that high anyway.
Oh, never. Our turbidity on this, the highest turbidity I've had on this with finished water, like in the middle of winter, is like 0.45. And that's like really, I worry when I get it up that high. But usually in the wintertime, my turbidity runs somewhere between 0.2 and 0.35.
Okay. Wow.
So it's way underneath the 1.0 limitation for slow sand water filtration. And it's even underneath the fast sand filtration. We have a neighbor down here that has a fast sand filtration plant at what they call the Sleepy Hollow Trailer Courts right in Bridge.